We stand at a pivotal moment in Earth's history, a moment that will be remembered for generations to come. The Holocene epoch, a period of unusual stability that allowed human civilization to flourish, is over. This epoch, which began approximately 11,700 years ago after the last major ice age, provided a climate that was remarkably stable. Our planet is changing, its climate in flux. We are witnessing unprecedented shifts in weather patterns, rising global temperatures, and the melting of polar ice caps. The familiar rhythms of nature are shifting as we enter uncharted territory. Seasons are becoming less predictable, and extreme weather events are becoming more frequent and severe. The changes we are witnessing serve as a stark reminder of the impermanence of all things. The natural world, which once seemed so constant and reliable, is now in a state of flux. Even on a cosmic scale, change is the only constant. Galaxies rotate, stars are born and die, and the universe itself is in a state of perpetual evolution. The universe itself is not immune to this dance of creation and destruction. Supernovae explode, black holes consume stars, and new celestial bodies are formed from the remnants. Stars, those celestial giants that illuminate the cosmos, are born, live, and eventually die. Their life cycles span millions to billions of years, but even they are not eternal. Our own sun, the anchor of our solar system, will one day meet its end. It will expand into a red giant and eventually shed its outer layers, leaving behind a white dwarf. This is not a cause for immediate alarm. We're talking billions of years in the future. However, it serves as a reminder of the transient nature of all things, even those that seem most permanent. But it's a sobering thought that even the most enduring objects in our night sky are subject to the relentless march of time. As we bid farewell to the Holocene, we must adapt to the new realities of our changing world and the universe beyond. The Sun, a giant ball of burning hydrogen, is engaged in a delicate balancing act. Gravity pulls inward while the outward pressure from nuclear fusion in its core pushes back. This delicate balance keeps our star stable. But it's a temporary truce. Eventually, the Sun will exhaust the hydrogen fuel in its core. When this happens, the outward pressure will lessen. Gravity, always the patient force, will begin to win the battle. The Sun's core will contract and heat up. The outer layers will expand dramatically, engulfing the inner planets, including Earth. Our once life-giving star will become a red giant, a harbinger of its impending demise. This is not a unique event. It's the fate of all stars like our Sun. After its red giant phase, the Sun's outer layers will be cast off into space, forming a beautiful but fleeting planetary nebula. At the nebula's center, a small, dense object will remain, a white dwarf. This stellar remnant is the exposed core of the Sun, incredibly dense and hot. A teaspoonful of white dwarf material would weigh as much as an elephant on Earth. White dwarfs shine with residual heat, but they no longer produce energy through fusion. Over eons, they slowly cool, fading from white-hot to red-hot. They become cosmic embers, remnants of a star's once fiery existence. The universe is littered with these stellar ghosts, silent witnesses to the cyclical nature of cosmic evolution. As white dwarfs continue to cool, they eventually reach a point where they emit no significant heat or light. They become black dwarfs, cold, dense relics of dead stars. Black dwarfs are theoretical objects. The universe is not old enough for any white dwarfs to have cooled to this stage. But their existence is predicted by our understanding of stellar evolution. The transition from white dwarf to black dwarf marks a significant stage in the universe's evolution. It's a step towards a colder, darker future. As more and more stars burn out and fade away, the universe will be populated by these stellar remnants, like tombstones marking the passage of time on a cosmic scale. Section 5. Life in a dying cosmos. A glimmer of hope? The prospect of a dying universe, cooling and darkening over eons, might seem bleak. As stars exhaust their fuel and galaxies drift further apart, the cosmos appears to be heading towards an inevitable end, but even in this fading cosmic landscape, the possibility of life endures. The universe, vast and mysterious, holds many secrets, and life has a way of surprising us. Life as we know it is tenacious and adaptable. On Earth, we find organisms thriving in the most inhospitable places, from the crushing depths of the ocean to the scorching heat of volcanic vents. It finds a way to thrive in the most extreme environments on Earth. These extremophiles challenge our understanding of the limits of life. Who are we to say that life couldn't exist in environments far different from our own? The universe is filled with diverse planetary environments, each with its own unique conditions. Perhaps on worlds orbiting white dwarfs where the light is dim but steady, life could find a niche. Or even on the remnants of shattered planets around black dwarfs, life finds a way. These environments, though harsh, might still harbor the conditions necessary for life. Maybe it harnesses energy from sources we haven't even imagined, adapting to the changing cosmos in ways we can't yet comprehend. Utilizing the faintest whispers of energy in a dying universe, life could persist, evolving to meet the challenges of its environment. The possibility, however remote, is a testament to the potential diversity and resilience of life itself. In the vast expanse of the cosmos, hope remains a glimmer in the darkness. Section 6. The end of matter, proton decay. If current theories are correct, even matter itself may not be eternal. Protons, the building blocks of atoms, are thought to be incredibly long-lived, but not truly immortal. They may decay over unimaginably long timescales. This process, known as proton decay, would have profound consequences. If protons decay, then all matter in the universe is ultimately unstable. Stars, planets, even ourselves, are composed of atoms which are in turn made up of protons, neutrons, and electrons. If protons decay, then everything we know will eventually dissolve into a sea of subatomic particles. The universe, as we understand it, would cease to exist. Section 7. Black hole evaporation, the slow fade of gravity's giants. Black holes, often portrayed as cosmic vacuum cleaners, are not invincible. They too have a finite lifespan. Through a process known as Hawking radiation, black holes slowly lose mass and energy over time. This radiation is named after physicist Stephen Hawking, who first proposed its existence. Hawking radiation is thought to be incredibly faint, making it difficult to detect. It's a subtle quantum mechanical effect that occurs at the event horizon of a black hole, the point of no return. Over unimaginable stretches of time, black holes will evaporate completely, leaving behind only a faint whisper of energy. Even these cosmic behemoths, once thought to be eternal, will eventually succumb to the relentless march of time. Section 8. Dark energy and the expanding universe. The universe is not static, it is expanding. This expansion is not just the galaxies flying apart, like shrapnel from an explosion. It's the very fabric of space itself stretching. And this expansion is accelerating, driven by a mysterious force known as dark energy. We know very little about dark energy, but its effects are profound. As dark energy continues to push the universe apart, galaxies will become increasingly isolated. The night sky will grow darker as distant stars fade from view. The universe will become a vast, cold, and empty place, its expansion continuing unabated. This scenario, known as the heat death of the universe, is one possible end state, a consequence of the relentless expansion driven by dark energy. Section 9. Escaping the end, a universe of our own. Faced with the ultimate demise of our universe, whether through heat death, proton decay, or some other unknown process, it's natural to wonder if there's an escape route. The end of the universe is a concept that has fascinated scientists and philosophers alike for centuries. As we delve deeper into the mysteries of the cosmos, the question of our ultimate fate becomes ever more pressing. Some physicists have proposed the mind-bending idea that advanced civilizations might one day be able to create their own child universes as a means of survival. This concept, while seemingly outlandish, is rooted in the principles of theoretical physics and cosmology. The idea is that by harnessing the fundamental forces of nature, a sufficiently advanced civilization could potentially generate a new self-sustaining universe. This is highly speculative, bordering on science fiction. Yet, many of the technologies we take for granted today were once considered the stuff of science fiction. The line between what is possible and what is imagined is often blurred, especially when it comes to the vast, uncharted territories of space and time. Creating a universe is no small feat. It would require an unprecedented understanding of the laws of physics and the ability to manipulate energy and matter on a colossal scale. The Large Hadron Collider and other particle accelerators give us a glimpse into the kind of high-energy environments that might be necessary for such an endeavor. It would require manipulating energy and space-time on a scale beyond our current comprehension. Theoretical physicists are only beginning to scratch the surface of what might be possible. Concepts like wormholes, quantum fluctuations, and the multiverse theory all play into these grand ideas. But if we've learned anything from exploring the cosmos, it's that the universe is full of surprises. Every new discovery challenges our understanding and opens up new possibilities. The cosmos is a vast, dynamic place, and our journey through it is just beginning. Perhaps in the distant future, long after our own sun has burned out, the descendants of humanity or some other intelligent life form will find a way to escape the fate of our universe and create a new cosmic home. This vision of the future is both humbling and inspiring, reminding us of the resilience and ingenuity that define intelligent life. The possibility, however remote, is a testament to the enduring power of curiosity, ingenuity, and the human desire to explore the unknown. As we continue to push the boundaries of science and technology, who knows what incredible feats we might achieve? The future of our universe, and perhaps even the creation of new ones, lies in the hands of those who dare to dream and explore.